Hello, this is Lyann Luu and Jack Crawford's final Arduino project. So what we did is we made a temperature sensing displayer. So it detects the temperature of its surroundings and displays it on the LCD screen. Um, the LCD screen can be adjusted, so if it's too bright, they can adjust it with the potentiometer, so it can be dimmer or brighter depending on the user's preference. Also, um, if the temperature of the surrounding area is above 80 degrees Fahrenheit, the LED will begin to blink, alerting the user to go turn on a fan or AC or something. Also, the user can decide if they want to read the temperature in either Celsius or Fahrenheit by switching a switch. And if they are bored while watching the temperature, there's also a little radio function where they can play a melody and listen to it as they're, to bring the temperature. So this is our code. So we begin by kind of starting to include the library for the liquid crystal, the LCD screen. And here we start to define our variables. So we can say our temperature variable is going to be this, the temp val, voltage variable is going to be volts, final temperature variable is going to be temperature C and temperature F, which is Celsius and Fahrenheit respectively. There's also other variables such as where the switch pin is located, so that switch pin is equal at 10, button pin is at 8, counters starts at 0, buzzer pins at 9. There's 18 beats in the song, so there's 18 as the variable. These are the character notes that are being played, and then the beats of the song, and as well as the tempo. So, yeah. Here we begin the void setup. So in the void setup, we start to declare the outputs and the inputs that will be found in the code. And they'll help the program. Then we go to void loop, where we have 4 different void loops to work with. So read temp is the void loop where you can read the temperature. LED red is the void for the LED to tell it to blink. Switch F to C is the void loop that displays the temperature on the LCD screen and allows the user to switch between Fahrenheit and Celsius. And the final void loop is buzzer sound. And the buzzer sound is what it sounds like. It's the void loop that allows the buzzer, to be played when pressing the button. So first void loop is read temp. And for read temp, this is our code for it. It's a little bit long, but it's necessary to read the temperature. So what we have here is first the serial, it'll detect the serial print, the temperature value. And then once the temperature value is detected, then it'll convert that to the volts by multiplying the temperature value by 3.3. And it cannot equal 1023.0. Then the volt is then subtracted by 0.5 and multiplied by 100 to get the Celsius. And when you get Celsius, then you multiply that Celsius value by 9.0 and divide by 5.0, and you add 32 to determine the Fahrenheit. So, so through all that, you get Celsius temperature and the Fahrenheit temperature, which is later used to display the Fahrenheit and Celsius. Those will be the variables that allow us to bring that into the switch code. All right. Moving on, we have void LED red, and here we have a conditional. So if the temperature in Fahrenheit is greater than 80 degrees Fahrenheit, then the LED red light will begin to flash off and on 4 times. And if it's under 80 degrees Fahrenheit, so if it's like 79.9 or below, then it'll just stay off. So pretty self-explanatory. Continuing on, we have the next void loop, which is switch F to C. So on switch F to C, we have a switch value, and that switch value equals digital red switch pin. So this will allow us to switch between two different if-else's. So we have the first, we have if, which is if the switch value is high, then it will print the temperature in Fahrenheit. But if they switch the other way, that's else, and that will begin to print temperature Celsius. So yeah, with that, they can determine if they want to read the temperature in Fahrenheit or Celsius. Moving on, we have buzzer sound, void loop buzzer sound. And in void loop buzzer sound, you have a conditional again. So if I equals 0 and I is greater than song length, then the beats will start going. That's how long it will go for. So if the notes equals that thing, then it will start delaying. And yeah, that's it. So here's the frequency. So this is where it's defined the frequency. So this is where all the notes from above in this area right here is defined. So all the C's are note 262, all D's are 294, all E's are 330, F's are 349, G's are 392, A is 440, B is 494, and C is 523. And that is it. Some other things to point out is that we have our outputs and our inputs. So our first output is for 13, and 13 relates to our LCD screen display. That is because when we have the user input, which is the environmental input, which is the temperature, it would display an output, and that output is displaying the temperature on the LCD. We also have our next input, which is the switch pin, and because it's the user's input, so the user is manually switching the pin, and it's coming out with an output, as in changing it from Celsius to Fahrenheit, Fahrenheit to Celsius. The switch pin is an input. And our last output is the buzzer pin. So that is an output because when you press the button, that's an input, and when you press the button, that's an output because when you press the button, it will send messages to the buzzer to display sounds output. So here we have a loop. So in this loop, this will continually repeat over and over. So every time the temperature is 80 degrees or higher, it will begin to loop. So it will begin to blink 4 times the LED. But if the temperature is under 80 degrees, it will not blink. That is a loop because it will keep coming back to this this void, and it will continue to see if the temperature is over 80 degrees. Also, the switch pin, so the void loop switch F to C, is a function because we're having an input, which is a switch pin, and every time we switch it, we're producing an output. And that output is either Fahrenheit if you switch it to high, or you switch to low, that will be Celsius. Going back to void loop LED red, this is a range because there are many values that can be part of this conditional. So the range is if anything above 80 degrees is temperature F, then the light will start blinking. So if it's 80, 81, 82, 83, all the way up to like 200 degrees Fahrenheit. So that's a range. Additionally, we also have some constants in our code. So our constants are switch pin, button pin, buzzer pin, and song length. So throughout our code, these are the things that will stay constant throughout the entire time. So switch pin will always be 10, button will always be 8, buzzer pin will always be 9, and song length will always be 18. So no matter all the changes in the code and the program, these values will always stay the same. So these variables will always be 10. Switch pin will always be 10, button will always be 8, buzzer pin will always be 9, and song length will always be 18. We also have a counter here, so this is counter equals 0. And counter equals 0 basically means that in this code, when the button hasn't been hit yet, that's when counter equals 0. When it's hit once, then the counter will change to 1. And that is also an operator, which we will be talking about soon. And when you hit it one more time, the counter will go back to 0. So this counter basically determines which step the button is on and what it should do. So here's an example of a operator in our code. So in this operator, we are multiplying temperature value by 3.3. So multiplication basically means you're going to multiply this with this. That is an operator. Thank you for watching this video. I hope you enjoyed learning more about Jack Crawford and my Lyann Luu's final Arduino project. Yay!